Through innovation and technology, Active Treatment Systems provides water treatment solutions to protect the environment from pollution, damage, and any endangered species from possible extinction. Bass Lake is situated in the Sierra National Forest, approximately 14 miles from the south entrance to Yosemite National Park. The lake is approximately 4 miles long and 1/2 mile wide. The current dam was completed in 1911 by Pacific Gas and Electric and was the first hydroelectric generating project in Central California. Today it generates 27 megawatts of power through 5 downstream powerhouses. The dam is a hydraulic earth and rock fill embankment with a thin central concrete core wall. The overall structure is 145 feet high, 1,880 feet long, with a crest of 3,380 feet of elevation. PG&E developed a retrofit design to modify the dam to increase its stability to meet current state and federal safety guidelines. The dam modification consists of the addition of approximately 253,000 cubic yards of granite rock fill, quarried on site to selected areas on the upstream and downstream faces of the dam, raising the structure 8 feet. The large area of land cleared for the dam improvements resulted in turbid water during storm events. Active Treatment Systems was contracted to remediate all stormwater runoff which was collected in a small basin and multiple tanks. One of the challenges for this system design was the limited space for stormwater collection due to the nature of the sloping terrain and limited flat space. Water collection occurred in a basin at the base of the sloping open excavation and was pumped into a 20,000-gallon tank before being transported 220 vertical feet to an additional 8 tanks, each holding 18,000 gallons. Before the water entered the first treatment tank, it passed through the ATS control unit where water quality was automatically monitored and recorded. The turbidity of the collected stormwater ranged from thousands of NTU to tens of thousands of NTU. The biodegradable polymer chitovan was used in the water treatment process to cause the suspended solids to agglomerate and settle to the bottom of the holding tanks in clumps. The polymer was metered in at a rate based on the results of the first bench scale treatability test for the day. While settling in the series of tanks, the polymer acted on the suspended solids, causing coagulation and flocculation, resulting in the solids settling to the bottom of the tanks, thus reducing the turbidity. pH was also monitored to assure that it was in the neutral range of 6.5 to 8.5. If it was outside this range, it was either raised with a base or lowered using an acid. The final step in this treatment process is called chemically enhanced sand filtration. Additional polymer in the range of 1/10 of what was used for pre-treatment was added prior to the sand filters. Treatment with the chitovan polymer allowed ATS to discharge stormwater at less than 10 NTU, which is below the California Construction General Permit requirements for stormwater discharges. The ATS computer monitored the water quality prior to discharge, and if it met the permit spec, it was released back into the environment, which in this case was a stream emptying back into Willow Creek. All of the early challenges for this project were overcome, and the treatment activity went as planned. Careful planning for system operations was carried out for every expected storm to assure that there were ATS certified water treatment technicians on standby and available to operate when the storm began. There were many other contributors to this project's success, including PG&E, ERM West, Provost and Pritchard, Kiewit, Amec, and Parsons. The ATS goal for all of its projects is to keep the water being treated from causing damage to the environment and to protect their customers from fines resulting from an out-of-spec discharge.